Okay, so finally, what we can say about these operators, these AK lambda dagger and AK lambda are the or correspond to creation and the annihilation operators for a photon of electromagnetic field that is propagating in with some wave vector k and has a polarization given by epsilon k lambda. Yeah, so this is what we intend to start with, or basically want to complete with. So finally, what we can say about here, finally, uh, it will it will be these operators. Which ones? Uh, AK lambda with a vector sign dagger, which corresponds correspond to creation of a photon of a photon of EM field at wave vector k and polarization epsilon k lambda cap. Yeah. So Uh, basically, we can also express our Hamiltonian, the one we have derived earlier, in terms of these capital AK lambda and AK lambda dagger. So the Hamiltonian can be derived in terms of AK lambda dagger and AK lambda. कैसे so we start with that equation Hamiltonian की equation जो हमने earlier लिखी थी और if you remember so since the Hamiltonian was in fact H is equals to 1 over V summation over K and lambda, that is you sum over all K values and two polarization direction, that is sum over K, and then we have 2 pi C square bracket pk lambda dagger plus pk lambda dagger and pk lambda, and then we have plus k square over 8 pi times qk lambda and qk lambda dagger plus qk lambda dagger and qk lambda, this, and the bracket is closed. So we change first of all P and Q. That is, we change first of all these terms, and these terms in circular bracket in terms of AK lambda and AK lambda dagger, and similarly AK lambda and AK lambda dagger terms में, और इनको अलग अलग अगर हम दोनों इक्वेशंस को ले लें, so we would have let's say 1 upon 2 1 over V, the volume part, times summation over K comma lambda 2 pi C square uh, P के लैम्डा एन पी के लैम्डा डैगर, और इसके अंदर अगर हम सब्स्टिट्यूट करें तो हमारी कुछ इक्वेशन पाई सी स्क्वायर ओवर वी समेशन ओवर के लैम्डा ऑफ के ओवर 4 पाई सी होल स्क्वायर, और फिर हमारे पास वो टर्म्स आ जाएंगी जो इन टर्म्स ऑफ ए के लैम्डा डैगर प्लस ए माइनस के लैम्डा और ए विद अ डैगर साइन ए के लैम्डा, फिर माइनस ए के लैम्डा एंड ए माइनस के लैम्डा, and the last term with both daggers minus a dagger k minus k lambda and a k lambda dagger. Yeah. And similarly you can write for the q's, और फिर ये आप सब्स्टिट्यूट करेंगे तो फैक्टर्स कैंसिल आउट हो जाएंगे. सो अगेन 1 ओवर ये जो फैक्टर आपके पास आ रहा है हाफ, we are introducing this factor half to avoid double counting. Yeah. Why double counting? Because we have included e to the power iota kct plus traveling wave and e to the power minus iota kct negative direction traveling wave, and for both p's and q's. Yeah, so in order to avoid double counting, because this e to the power plus iota kct and e to the power minus iota kct would be included for q as well as for p. So अगर हम हाफ का नहीं लगाते तो वी वुड बी डबल काउंटिंग, और उस डबल काउंटिंग से बचने के लिए हमने यहाँ पर ये हाफ का फैक्टर लगा दिया. तो सिमिलरली समेशन ओवर के कॉमा लैम्डा के स्क्वायर ओवर 8 पाई टाइम्स क्यू के लैम्डा एंड क्यू के lambda dagger, and this would be equals to 1 upon 16 pi v times sum over k comma lambda, or this is k square, and then we have those terms a k lambda dagger plus a minus k lambda dagger, or minus sign here as well, and a k lambda with a minus sign plus a k lambda or a minus k lambda plus a minus k lambda dagger, a k lambda dagger. Yes. So you see these factors है ये कैंसिल आउट हो जाएंगे, बिकॉज इनका जब हम इन दो वैल्यूज को यानी इसको और इसको सब्स्टिट्यूट करेंगे इस इक्वेशन के अंदर, जो हमारे पास ये हैमिल्टोनियन की इक्वेशन है, इस इक्वेशन के अंदर, तो हमारे ये जो दो फैक्टर्स हैं ये आपस में कैंसिल आउट हो जाएंगे. लास्ट टू फैक्टर्स इन बोथ पी के लैम्डा एंड पी के लैम्डा टर्म, पी के लैम्डा डैगर एंड क्यू के लैम्डा एंड क्यू के लैम्डा डैगर टर्म्स है. एंड सो जो हैमिल्टोनियन हमारे पास आ जाएगा, दैट हैमिल्टोनियन वुड बी एच एच इज इक्वल्स टू 1/v summation over k comma lambda k square over 8 pi times a k lambda a k lambda dagger plus a minus k lambda dagger and a minus k lambda, plus we have complex conjugate terms. Gate terms, yes. And similarly, we could substitute for these values ए के और ए के लैम्डा के स्मॉल ए के और ए के लैम्डा की टर्म्स में सब्स्टिट्यूट कर दें, सो एच वुड बी इक्वल्स टू 1/v टाइम्स sum over k lambda, that would be k square upon 8 pi v, sorry 8 pi टाइम्स जो स्केल फैक्टर था 2 पाई h bar c v over k, yeah, times ak and ak lambda dagger with a vector sign plus a minus k lambda dagger or a minus k lambda plus the CC term, complex conjugate. Yeah. So this is basically, so we have, and similarly यहाँ पर भी ये ब्रैकेट नहीं आएगा, ये ब्रैकेट हमारा आना चाहिए यहाँ पर, ठीक है। सो अब अगर इसको सिंप्लीफाई कर लें, सो द सिंप्लीफिकेशन के बाद h वुड बी इक्वल टू समीशन ओवर a lambda half h bar c k factor, or that would be half, नहीं not half, this is wrong, that would be 2 जो है 8 से कैंसिल होगा तो दिस इज 1/4, और ये v और ये v कैंसिल हो जाएगा, ठीक है ना। सो हमारे पास आएगा h बार c के टाइम्स a के लैम्डा a के लैम्डा डैगर प्लस a के लैम्डा with a minus sign and a minus k lambda plus cc. और we can use the commutator for AK and A dagger, that is using AK, या rather joining करने, so AK कॉमा A लैम्डा ये बराबर होता है किसके, A के, सॉरी ये नहीं रखें, इन जनरल करें बिकॉज दोनों फिर सबस्क्रिप्ट लगानी पड़ेंगी, सो वी हैव A and A dagger minus A dagger A, and this is equals to 1 होता है, so it means we could write A dagger equals to A dagger A plus 1, या और इसको अब हम सब्स्टिट्यूट कर दें तो हमारे पास जो इक्वेशन आ जाएगी दैट वुड दो टर्म्स होगी, और उन दो टर्म्स के अंदर हम कुछ, यानी फर्स्ट टर्म की जगह, यानी इस टर्म की जगह हम ये सब्स्टिट्यूट कर दें तो आपके पास क्या आ जाएगा, दो टर्म्स आएंगे देन कैंसिल हो जाएगा 2 से, so summation over k lambda, so this 1/4 would be cancelled by 2 जो कॉमन निकालेंगे, so we would have 2 h bar c k, और जो बचेगा वो a k lambda dagger और a k lambda प्लस a minus k lambda a with a dagger sign here minus k lambda plus 1, yeah. So बेसिकली जो आपके पास यहाँ पर टर्म आ रही है, जिसको हम ये माइनस में जो टर्म आ रही है, दैट टर्म वुड करस्पॉन्ड टू सम ओवर ऑल के वैल्यूज, and that would correspond to some divergence, yeah, some ground state divergence. So for now उसकी हम बात नहीं करें। ग्राउंड स्टेट डाइवर्जेंस से मुराद ये है कि हम जीरो पॉइंट एनर्जीज, वी कैन सम ऑल द जीरो पॉइंट एनर्जीज, and if you could sum all the 0 point energies, then that would result in a divergent sum. Yeah. And so इसको रिप्रेजेंट किया जा सकता है कैसे? सो इसको सिंप्लीफाई अगर हम कर लें, सो इसको हम रिप्रेजेंट करते हैं समीशन ओवर के लैम्डा एज एच बार सी के। ये हाफ अंदर मल्टीप्लाई हो जाएगा, एंड दिस वुड बी इक्वल्स टू ए के लैम्डा डैगर, a k lambda plus half. And so this half would correspond to 0 point energy, corresponds to 0 point energy with a divergent sum. So हम इस divergent sum को हमेशा निकाल सकते हैं, because that would result in a Hamiltonian which would be divergent or infinite. But nevertheless, for now we keep it. This Hamiltonian, you can think about this Hamiltonian as a set of harmonic oscillator, and each of these harmonic oscillator has a specific number operator corresponding to a specific value of k and lambda. So we can say these Hamiltonian or rather this Hamiltonian sum over n is that for a set of harmonic oscillator, harmonic oscillator, oscillators each with its each with its own number operator. Yeah. And so we could think about that number operator n k lambda, which is equals to किसके बराबर होगा? That is a k lambda, the dagger. Yeah. And then we could think about the commutator. So nk lambda comma a k lambda, that would result in a k lambda with a dagger sign here. So dagger. Similarly, n k lambda or a k lambda, that would correspond to minus a k lambda without dagger. और इससे हमें ये पता चलता है, this shows that a k lambda dagger and a k lambda are creation and annihilation operator. Why? Because when you have a commutator between the number operator and let's say creation operator, what you get is a creation operator. So if you apply a wave function, that is, you apply the if you apply this operator, this is some operator, yeah. If you apply this operator on some state vector, then that would result in a creation of a particle in that state vector or in that particular state. And similarly, if you apply this operator, दूसरा वाला, on some state vector, that would lead to the annihilation of a particle in that particular state. That's why हम यहाँ से ये conclude करते हैं कि AK lambda dagger and AK lambda, these are creation and annihilation operator. That is, they create quanta of radiation and annihilate a quanta of radiation. That is A k lambda dagger and A k lambda are creation and annihilation operators responsible for creation and annihilation of quanta of radiation. Yeah. So this is basically what we conclude from this. Uh, and in the case of photon, we would have a photons of wave vector k and polarization uh, epsilon k lambda. So, and in case of photons, we would have a photon of wave vector k and polarization epsilon k lambda. Yeah. So in this sense, what we have done, we have basically quantized the electromagnetic field. यहाँ से हमें ये पता चल रहा है because of this creation and annihilation of a quanta of radiation, that basically making sense that we have basically quantized our electromagnetic field. So to conclude, that is, we have quantized EM field. Yeah. हम इसी तरह से ये जो फील्ड ऑपरेटर्स हैं इनको इन टर्म्स ऑफ एनाइलेशन और क्रिएशन ऑपरेटर्स की सूरत में लिख सकते हैं. सो ये जो फील्ड वेरिएबल्स हैं रादर, सो फील्ड वेरिएबल्स क्यू के लैम्डा एंड पी के लैम्डा कैन ऑल्सो बी एक्सप्रेस्ड as can also be expressed in terms of creation oblique annihilation operators, meaning कैसे? So that would mean qk lambda is equals to under root scale factor 2 pi h bar cv over k times a k lambda e to the power minus iota k ct plus a minus k lambda dagger e to the power plus iota k ct. Yeah? And similarly, pk lambda, again the scale factor 2 pi h bar cv over k times iota k over 4 pi c times minus a k lambda e to the power minus iota k ct plus a minus k lambda dagger e to the power iota k ct. Yeah. So basically what we have done is, in fact, the field variables or the operators, field operators qk lambda and pk lambda expressed in terms of the creation and the annihilation operators. Yeah, that is field operators qk lambda and pk lambda expressed expressed in terms of ak lambda dagger and ak lambda, that is creation and annihilation operator. Therefore, finally, अब हम जो हमारे पास तीन वेरिएबल्स थे, दैट इज द पोटेंशियल, इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड, उसको भी इन टर्म्स ऑफ दीज एनाइलेशन एंड क्रिएशन ऑपरेटर्स की सूरत में लिख देते हैं. देयरफॉर फाइनली द पोटेंशियल A of r comma t, E of r comma t, and B of r comma t can be expressed in terms of operators. AK lambda dagger and AK lambda. Yeah. And so क्या हो जाएंगे equations? Those equation A of r comma t vector notation, which is summation over k comma lambda. Then we have 2 pi h bar c over kv times epsilon k lambda, that is the polarization vector, times ak lambda e to the power plus iota k dot r minus kct plus a k lambda times e to the power minus iota k dot r minus kct, this and this vector. Similarly for B or E, that would be iota summation over k comma lambda, then the normalization factor 2 pi h bar ck over V times epsilon k lambda, which gives you the polarization direction, then ak lambda e to the power iota k dot r minus kct minus sign a k lambda dagger with e to the power minus iota k dot r minus kct and this bracket close. And then finally B of r comma t, these are all vectors, which is equals to iota summation over k comma lambda, again the scale factor 2 pi hc h bar c over kv times k vector crossed with the polarization vector times ak lambda e to the power minus iota plus iota k dot r minus kct. Then we have a minus sign ak lambda dagger e to the power minus iota k dot r minus kct and this whole bracket close. So in all, what we have done, we have quantized everything. So uh, these are basically the correct expression for the quantized field. And although the treatment is very long, but it is in fact a very good treatment for quantizing any type of field. And that this could this you can use this treatment if you want to study something in quantum field theory or particle physics. Yeah. So we could say these are are correct expressions for the quantized field. So we have successfully quantized the field. Yeah. Uh, we could also think about the free energy. So the total energy can be given by the Hamiltonian, and that free energy can be represented with that Hamiltonian जो इससे पहले हमने किया. Um, these expressions are consistent with the total free energy. Total free energy. And what is that? That is basically H is equals to summation over K lambda जो इससे पहले हम निकाल चुके हैं H bar K of NK lambda plus half. And this is uh, which include the divergent or diverging 0 point energy. Yeah, so this basically completes, in fact, the treatment for quantization of field. Now, there is one very important aspect जो हमें discuss करना है, and that aspect has to do with sort of verifying argument that to any electromagnetic field there is a quantized intrinsic angular momentum as well. That is, photons have intrinsic angular momentum. Yeah. And because when we say photons have intrinsic angular momentum, so we need to justify that epsilon k lambda factor जो polarization को represent कर रहा है. And that polarization factor, when described in terms of angular momentum, then that is something which is basically some intrinsic property. So the next, in fact, we want to do is to sort of prove the fact that this free field theory, or that is this free field which is quantized, has a linear momentum as well as an intrinsic angular momentum. So let's talk about free field momentum. Free field momentum. And why? To justify our argument regarding intrinsic linear momentum and intrinsic angular momentum. Yeah. ये दो points हमें verify करनी. So let's start with a linear momentum of an electromagnetic field. और हम उसको, let's say we represent it with some symbol. Let's say we represent it by capital G. So the linear momentum linear momentum of the EM field, which is free, let's say, uh, is expressed as कैसे? We can write it as, let's say we use the symbol G for the linear, और angular momentum को किसी और से represent करेंगे 1/4 pi c. This expression जो मैं लिख रहा हूँ, that is obtained from your course in electromagnetic theory, and this is an integral over the sum of in three space, summing over in three space of the Poynting vector, which is E cross B. Yeah, so the direction of propagation of wave would be perpendicular to both E and B, and that would represent some momentum. That is the momentum, linear momentum in the direction perpendicular to E and B. That is basically the cross product of E and B. And now we basically substitute the values of E and B in this equation जो हमने ऊपर निकाली. Yeah, and इस बात का ख्याल रखते हुए कि we have a space for E, we have a space for B, and so the integral would be a double integral, yeah, or double sum rather, yeah. And so ये हमारे पास जो equation होगी, that would be G, which is equals to the factor जो कि common है 4 pi C common factor. Then we have an integral d3r, and we are summing over two spaces, a k lambda space है और a k prime lambda prime space है. K prime lambda prime space, and then we have this iota square coming from both terms of E and B, जो ये आपने ऊपर लिखी हैं फील्ड इक्वेशंस. सो बोथ हैव दिस आयोटा, ये भी आयोटा है यहाँ पर और यहाँ पर भी आयोटा है, सो दैट वुड बी आयोटा स्क्वायर, एंड ऑब्वियसली आयोटा स्क्वायर का मतलब होगा कि दैट वुड रिप्रेजेंट -1, या. सो जो हमारे पास फैक्टर आ रहा होगा, दैट वुड बी आयोटा स्क्वायर एंड अंडर रूट में फैक्टर 2 pi h ओवर v, एक से, और दूसरे से 2 pi h ओवर kv, दूसरे से, yeah. And then we have the epsilon k lambda coming from E and crossed with जो B के साथ है, that is k prime cross E k prime lambda prime, ये फैक्टर जो B से आ रहा है, बट दोनों के दरमियान क्रॉस है बिकॉज ये वाला क्रॉस इस वाले क्रॉस को रिप्रेजेंट कर रहा है, टाइम्स अब वो फैक्टर जो हमारे